Good afternoon, 6th and 7th graders. Today's math lesson is going to be all about least common multiple, also known as LCM, and equivalent fractions. Now, 6th graders, your lesson is mainly on least common multiples. 7th graders, your lesson is going to be mainly on equivalent fractions. However, they are both useful and needful. So I want you to listen to both of them, take notes on both of them, so that 6th graders, when you start equivalent fractions, you won't have any problems. Alrighty. Now, so let's go ahead and begin by talking about least common multiples. We have two methods of finding the least common multiple. Now, last lesson, we discussed one of my favorite terms, which is the GCF, the greatest common factor. All right, remember with greatest common factor, we would have two numbers, let's say 12 and 24. This is just a little review. All right, I'll put that word up there, review. Alrighty, and we would have to list remember the F stands for factors, so we have to list the factors of 12 and the factors of 24. So we would say 1 times 12, 2 times 6, 3 times 4. So that's all the factors of 12. And then for 24, we would have 1 times 24, 2 times 12, 3 times 8. Let's see, 4 times 6. And that is it. Alrighty, so we would list our factors, and then we would say, okay, what are the factors that they have in common? Well, we got a 12. Let's see, we also have a 2. We have a 6, a 3, 4. Yeah, it has a lot of factors in common. And of course, we would then ask the question, well, what is the G? What is the greatest that they have in common? And we would say, okay, well, the biggest number would be the 12. So our GCF in this problem would be 12. Okay, now, of course, remember, GCF is useful if you need to divide these two numbers. You know that, oh, well, if I have the fraction 12 over 24, I can divide this guy by 12. Oops, little glitch. And I can divide this guy by 12, and then I can reduce my fraction. And that would give me 1/2. Okay, so we know that 12/24 is the same as 1/2. So that's what we did last class. Now, this time, however, instead of listing factors, we're actually going to list multiples. Alrighty? Now, if you forgot to write any of that down, or if you needed to write any of that down, you could just pause and rewind it. All right, so now with a multiple, we have to ask the question, first off, what is a multiple? So if I ask you, okay, what are the multiples of 2? You should answer 2, 4, 6, 8, 10, 12. You notice I'm counting by 2s. If I were to say, what are the multiples of 3? I would say 3, 6, 9, there we go, 12, 15, and such and so forth. So a multiple is when you take a number, and this is just my common definition, it's when you take a number and you count by that number. Alrighty? So, and I like to, the easiest way I always think about it, if I say, okay, multiples count by 2s, and that helps me remember that a multiple means to count by whichever number you're dealing with. Alrighty, so like I said, and I believe I said this at the beginning, if I didn't, I'll say it again. We have two methods of finding our least common multiple. Okay, method number 1. Oops, there we go. Method 1 involves, just like I showed you a second ago, if we have small numbers, let's say I have the number 4 and I have the number 6. All right, number 4 and number 6. Well, these two numbers are small, so all I need to do is to count by those numbers. All right, so let's count by 4. So we would say 4, 8, 12, 16, 20, 24, 28. Okay, and then I count by 6. That would be 6. Oops, excuse me. 12. There we go. 18, 24, 30, and such and so forth. And we could just keep on going. Now, with least common, that means what is the smallest number, the smallest multiple that they have in common. And we can see that the smallest multiple that they have in common would be this 12. So our LCM is 12. Okay, so remember, with the multiple, we find the least. With a factor, we need to find the greatest or the biggest. All right, so this is method 1. And remember, it only works for small numbers. Now, let's say that you have something a little bit bigger. All right, and this brings us to method 2. All right, method 2. And I actually kind of like method 2 personally. I don't know, it's just something about it. It just lights my fire. All right, let's say I have the number 24 and the number 36. Notice how I'm setting it up, because method 2, you work it out in a different way. All right, so 24 and 36. Now, I could count by 24s and I can count by 36s. It might take me a while because, I'm going to have to work each and every problem out. So instead of using that whole counting by method that we would use with small numbers, we're actually going to use what we call the factor method. Okay, and that's why I reviewed the GCF. All right, so factor method. And with this factor method, we're actually going to prime factorize these two numbers, and then take those factors, multiply them together, and then we'll get our lowest or our least common multiple. Watch how that goes. All right, so now all I need to do to start is to pick one factor of 24. I like the number 4 times 6. That is a factor of 24. 4 times 6. All right, so now my goal is to break each of these numbers down into only prime numbers. Well, 4 is not prime, it's composite, so I need to break that down again. What are some factors of 4? Well, 2 times 2. Ah, good. 2 is prime, 2 is prime, so that side is completely finished. Now this 6, on the other hand, he is also composite, so I need to break him down. All right, what's a factor of 6? Well, 2 times 3. 2 is prime, 3 is prime. So finally, I am finished. So that means the factors of 24 are 2 times 2 times 2 times 3. Now, if I wanted to check my work, which is always good to check it, if I multiply all of these numbers together, 2 times 2 times 2 times 3, I should get 24. Okay? Now, let's go ahead and prime factorize, or find the prime factorization of 36. Well, in this case, I'm going to start with 4 times 9. All right, so 4 is composite, so I'm going to go ahead and break that down. 2 times 2. 9 is also composite, so I need to break him down. 3 times 3. So there we go. We have 2 times 2, 3 and 3. Those are all primes, so I'm now finished. All right, so the prime factors of 36 is 2 times 2 times 3 times 3. Now, 6th and 7th graders, this is a good way of writing our prime factorizations. However, I want you to start using exponents. And exponents are beautiful, gorgeous little creatures that make writing much easier. All right, so now, do you notice that I have 3 2's? Well, guess what? I can shorten that up by saying 2 to the 3rd power, because there are 3 2's. And of course, there's only one 3, so I just write him by himself. How many 2's do you see here? Well, there are 2 2's, so I say 2 to the 2nd. There are 2 3's, so I say 3 to the 2nd power. All right, you see how we do that? Now, that's how we do the factorization. Now, we need to take this one step further, because our goal isn't necessarily to just factor these. Our goal is to find the least common multiple. So we need to ask ourselves, what is the least common multiple? All right, so now this is what we need to do. And I'm going to go ahead and erase this. I need to erase this and get this out of my way. All right, and I'm going to rewrite it. Just watch what I do. All right, this is a fairly easy step. Now, of course, it's not easy if you mess it up, but it is very easy. All right, so watch this. So, like I said, the factors are 24, right? When I did my prime factorization, I got 2 times, whoops, got a little glitch. Remember, that won't stop us from learning, right? So 2 times 2 times 2 times 3. There we go. And remember when we did our factorization of 36, we had 2 times 2. Oh boy. Let's fix that. Times 2 times 3 times 3. All right, so now watch carefully what I do. All right, so do you notice that these 2's right here create a pair? All right, so that gives us 1, 2. These create a pair, which gives us another 2. This guy is by himself, but that's okay. I'm going to still take him. So now I have 3 2's. All right, then I have these 2 right here create a pair, which gives us 1, 3. And this guy is by himself, but I still write him down. Okay? You see that? Now I'm going to take all of these numbers and I'm going to multiply them together. What's 2 times 2? Well, that's 4. 4 times 2, 8. 8 times 3, 24. 24 times 3 gives us 72. Alrighty? So our LCM equals 72. Alright, so you see how we did that? That's not too bad, right? That's not too bad. Alrighty, so let's do another problem. Alright, so here we go. Let's try another one. Okay. We have the numbers 4 and actually no, let's not do 4. Let's do the numbers 9 and 12. 9 and 12. Alright, so here's my question. Here's my very first question. Am I going to use method 1 where I simply count by 9s or count by 12s, or should I use method 2 where I factor them out? Well, these numbers are relatively small, so I actually can use method 1. Now, method 2 also does work for small numbers. It's not like if you use method 2 on a small number that it won't work. But I can use method 1. All right, so let's use method 1. So we're going to count by 9s. All right, so we know that the first one will be 9, 18, 27. Then we have 36 and 45. All right, so I'm going to stop there. Let's hope we have enough. Now let's count by 12s. So we would have 12, 24, 36. Oh, guess what? I can stop already. Do you see why I can stop? Exactly. 36, 36. So my LCM equals 36. All right, simple as pie. Excuse me. Let's try another number. Oh, let's do this guy. Let's erase. Let's do this one. How about for the number, yep, 20, no, let's do 14 and 25. 14 and 25. Now, am I going to use method 1 where I count by these, or count by 14s and count by 25s, or should I use method 2 where I factor them out? Well, of course, like I said, I can count by 14 and I can count by 25. It'll take me a moment, but I'll get there. But I don't want to do that. I'm going to go ahead and use method 2 where I factor them out. Alrighty, so let's go ahead and set these up to factor them. Now, what I want you to do, I want you to pause this video, and go ahead and start factoring them out, and then you can watch me work through it. Let's see if you can figure it out yourself. Alrighty. Now, so let's go ahead. Here we have 14. We have 25. Let's start off with the multiple. Let's see, 7 times 2. 7 is prime, and so is 2. So we have no problems. We're done there. That's good. All right, now let's see about 25. Let's do 5 and 5. Okay, 5 is prime, and so is 5. All right, so look how easy that was. Now, what are we going to do? We are going to take, all right, so we're going to take these numbers. We're going to take the 5 and the 5, 5 times 5, multiply it with the 2, multiply it by the 7, and when we multiply all of those numbers, guess what we're going to get? 350. Now imagine if you had used method 1 on these two numbers, you would have had to multiply up to 350 in order to find the LCM. Alright, so notice this method is a whole lot faster, especially for the large numbers. Okay, so that's really simple, correct? Least common multiple. Now let's talk about these gorgeous equivalent fractions. Alright, 7th graders, that's where you're going to find most of your work. Alright, or at least in your book, most of your work will cover equivalent fractions. Alrighty, so this is how we're going to begin. Alright, so we're going to take these two circles, okay, when we're talking about equivalent fractions, just so I can demonstrate it to you. Like I said, you should already know this, but just in case you don't, just follow me, okay? So let's say that I take this fraction right here and I shade in exactly half of it. Alright, look at that, gorgeous. And so my fraction be 1/2 because half of the circle is shaded. Well, let's say that on this pie, or this circle, which has 4 slices instead of 2, I shade 2 out of the 4. Alright, 2/4. Now, if you notice though, the shaded region occupies the exact same amount of space as each other. Therefore, that means that 1/2 is the same as saying 2/4. They are equivalent. They are the same. Because when you draw them out, like I said, they have the exact same amount of space colored in, or in this case shaded in. Okay, now of course if this was a perfect graph, they would be exactly the same, but as you can tell, one is a little bit bigger than the other, but that's okay. For demonstration purposes, it works. Now, before we get into the real work of equivalent fractions, we need to discuss this one gorgeous property, and it is the identity property of multiplication. Alright, so if I take a number, and I'm going to represent that number with the letter A, okay? If I take a number and I multiply that number by 1, guess what? I'm going to still get that number. And that's an easy example. That's a really easy property. For instance, let's say I had 7 times 1. Well, what's my answer? 7. So any number times 1 is that number. All right, so now we also have an identity property of division. Okay, so if I take any number, and I divide it by 1, guess what? I get that number. So any number divided by 1 equals that number. All right, so if I have 7 divided by 1, it equals 7. All right, so that's pretty plain and simple, right? We've seen that before, we've done that before, and that's really, there's nothing hard to that. All right, so now let's get into some problems. Let's go ahead and erase that. Let's start working these out, because really and truly the way to understand is by working them out. Alright, so let's say that we have this fraction right here, 3/5. If I want to create an equivalent fraction, I need to either multiply the numerator and denominator by the same number, or divide the numerator and denominator by the same number. In this case, I'm going to multiply it by the same number. I'm going to multiply this one by 3 and that one by 3. And what I get is 9/15. So I know that 3/5 is the same as saying 9/15. I can also do with, let's say I have the fraction 1/4. Well, if I multiply this one by 5 and I multiply this guy by 5, then guess what? I would have the number 5/20. So 1/4 is the same as 5/20. Now, let's try this. I'm going to put up a pair of fractions, and I want you to tell me, are they equivalent? Okay, make sure that they're equivalent. All right, here's your first example. We have 3/5. Actually, no, let's not do 3/5. Let's do, let's do 12/15 versus 4/5. And the question is, are these fractions equivalent? Take a few seconds, look at it, come up with your answer. All right, did you say yes or did you say no? The correct answer is yes, they are equivalent. Well, how do I know that? Well, I can say to myself, what do I need to divide 12 by to get to 4? Well, if I divide 12 by 3, that'll give me 4. And if I divide this guy by 3, oops, writing the wrong symbol. Let me erase and correct that. There we go. If I divide the 15 also by 3, because remember, if I divide this guy by 3, then I have to divide him by 3. That gives me 5. So since they both work out, guess what? These are equivalent fractions. All right, what about this guy? Let me give you another one. What if I had, let's see, what if I had, now let's do this guy. 3/5 and 15 over 24. Okay, take a few seconds. Are they equivalent or are they not? Well, if you did it right, your answer should be no. They are not equivalent. Well, how do we figure that out? Well, 3 times what can give me 15? 3 times 5. Well, if I multiply him by 5, then he has to be multiplied by 5. And that's where we find the error. 5 times 5 is definitely not 24. Therefore, this fraction, 5/24, is not equivalent to 3/5. Okay? So that's how we do that. That's pretty easy, pretty simple. All right, now another way of working with equivalent fractions is if you actually have a missing number. Okay? So let's say that I have 8/11 is equal to, because I'm already telling you that these are going to be equivalent, so I'm going to use the equal sign instead of a comma. So 8/11 is equal to 24 over some unknown number. Okay, now we have 2 methods of working these out. One is for our easy problems, and of course the second method is for our hard problems. Alrighty, so now first things first, I'm going to start with method 1, which is to simply look and see if I can multiply or divide by a specific number to get the other numerator. In this case, it's a numerator. Alright, so can I multiply 8 by anything to get to 24? Yes, I can. I can multiply 8 by 3. So if I multiply the numerator by 3, I multiply the denominator by 3, and I know that 11 times 3 is 33, so this n has to equal 33. So that's the easy method. Now this method won't always work, and I'm going to show you an example where it doesn't work because, well, you'll see exactly why, okay? Alright, so let me erase this and write this bad boy down. Let's say I have 4, 6 compared to an unknown number, okay, or equivalent to the fraction of an unknown number over 15. Alright, so here I go, starting with the easy method. Can I multiply 6 by anything to give me 15? Well, actually, no, I can't. 6 times 2 is 12, 6 times 3 is 18, so guess what? I can't multiply it. Therefore, I have to use method number 2. Method number 2 is a beautiful method. It's called cross multiplication, also known as, affectionately known as the butterfly method. Butterfly method. There we go. Now with the butterfly method, we're going to take and draw, basically it's almost like butterfly wings. So you're going to draw little butterfly wings around your numbers, okay, to form an X. Alright, so notice that the denominator is with the unknown number and the 4 is with the 15. So what I'm going to do is I'm going to start by taking this equal sign and bringing it down. I'm going to put my variable, meaning the unknown number, on the left side, along with the 6, because I'm saying 6 times n, so 6 times n. And I'm going to put the 4 on the left and multiply it by the 15. Alright, do you see how I set that up? So 6 times n on this side, 4 times 15 on that side. Okay? Now, what I do first is I'm going to go ahead and start by solving 4 times 15. And I know that 4 times 15 equals 60. So I rewrite everything. Alright, now what is this operation between the 6 and the n? Well, that's multiplication, exactly. Now, I have to get this variable alone. He doesn't like to be near people. He wants to be by himself. So we're going to make him happy. Alright, so that means that this 6 needs to move. Well, the inverse of multiplication is division. So that means I'm going to take the 6 times n and divide it. Now, since the 6 needs to move, I'm going to divide it by 6. That way he moves. And if I do it to this side, I have to do it to this side. And that's going to leave me n equals, well, what's 60 divided by 6? 10. So that means that this unknown number right here is 10. That is the butterfly method. All right, so let's practice that a little bit more. Let's try another one. Okay. Let's do 5/7 equals, let's do 15 over an unknown number. All right, so here's my question. Actually, no, let's do another number. Let's do 14. So 5/14. Okay, so here's our question. Can I multiply 5 by anything to give me 14? The answer is no, so I know I have to use the butterfly method. All right, so I'm going to take the 7 and the 14, circle them. All right, so that's going to be 7 times 14. And now I'm going to take the 5 times the n, circle it, and that's going to be 5 times n. Put my equal sign in between. Alrighty, now, first we start off with the 7 times the 14. What is 7 times 14? 7 times 14 is 98. We have 5 times n. Alright, so if I divide by 5, divide by 5, n will equal, now of course this won't work out perfectly, and that's sometimes what happens when you make up your own problems, but we can work that out. So 5 goes into 9 once, gives us 5, which brings us 4, 48. 5 goes into 48, it goes in there 9 times, which gives us 45, which gives us 3. Alright, so we can say 19. I'm just pretend that it rounds up to, actually, no, let's go ahead and get that decimal in there. This is actually going to work out. 0, put a decimal up here. So 5 goes into 36. So it's going to be 19.6 as our answer. Okay? So our unknown number right here would actually be 19.6. And yes, that actually can happen. So I'm glad you did get to see it. But that is how we do equivalent fractions. Okay? So now that's what I want you to do. I want you to go ahead and open up your books to the assigned pages. Like I said, 6th graders, yours is going to be the least common multiple section. 7th graders, yours is going to be the equivalent fraction section. And I want you to go ahead and start working those problems. Alrighty? I wish you the best of luck. Have a wonderful day.